Okay, so with our multiplying, multiplying fractions. So say I had 1/2 times 2/3. The beauty with multiplying and dividing, folks, is that you do not have to have these denominators matching, right? You can now multiply apples to oranges and so on and so forth. With that being said, with multiplying, it's just the top numbers, multiply those two together, and multiply the bottom together, right? So 1 times 2 is 2. 3 times 2 is 6. But again, I can go into a lowest terms, right? Because remember, rule of thumb usually is that if there's an even number on top and on bottom, oh, you can't see the other, oh shit, thank you, my bad. I know exactly what just happened there. Right. So when we're multiplying, right, as I said, you don't have to turn everything into apples to apples. We essentially just go right across the top, numerator to numerator, and denominator to denominator, right? So 1 times 2 equals 2. 2 times 3 equals 6. But again, as I was saying, if our numerator and denominator are even numbers, it can usually come down to a lower term. 2 goes into itself once, 2 goes into 6 3 times. Does that make sense? That's our lowest terms for that one. So lowest terms. My printing looks crappier than my writing. So, what if, actually let me give you one more. Okay, let's do this one. 2/5 times 1/3. Okay? Give that a quick shot. Yeah, no playing around too much with having to do too much converting on these ones. I got some jazz playing in the background like elevator music. Keeps me nice and calm and mellow. Alright, so remember with multiplying, we just go straight across the board. Numerator to numerator, denominator to denominator. So in this case, 2 times 1, left with that 2. 5 times 3 is 15. I don't think that we can go any lower. Do you guys? Because we can't split 15 in half, can we? Right? So I think that's our lowest term for that one. Right? We've got an odd number and an even. So that is our lowest term. Okay? So that's our fractions, our straightforward proper fractions. What if we had some mixes? Let's try 1.5 times 2.25. Now, I want to pull this up here. And I think it was there. Do you see here? And again, this won't show up on the video. You'll just hear me talking about it. But right here where it says improper fractions are needed to multiply and divide, right? So we have mixed fractions over here. Unlike adding and subtracting where we can isolate our whole numbers, when it comes to multiplying and dividing, I actually have to turn these mixed fractions into impropers, right? So I have to essentially make my numerator bigger than my denominator. So again, as a reminder of what is going to happen there, multiply the whole number by the denominator, add the top, right? So in this case, 1 times 2, 2 plus the 1, we have 3 over 2. Denominator stays the same. Same thing over here. Whole number times the denominator, add that numerator. So 2 times 4 is 8, plus the 1 is 9 over 4, right? So now we just carry on the way we did up top. Numerator to numerator, denominator to denominator. 3 times 9, 27. 27 over 2 times 4, which is 8. So it's an improper fraction, right? Bigger at the top than down below. So essentially, again, it's like saying 27 divided by 8, right? So 27 divided by 8 equals 3 wholes, right? 8 will go into 27 3 whole times. 8 times 3, we get 24, right? 7 minus 4 is 3. And again, just so you guys, just to keep with how we've been doing it, there's our whole numbers, our denominators, and our numerator, right? So whole number, 3, numerator is 3 over the common denominator, right? And that is that final answer there. Right? Whoop, whoop, whoop. Oh goodness. There we go. Okay. So how about you guys try? I'm going to give you this one to try. Okay. Maybe I'll take a snapshot of this one and put that off to the side. So you got that as your little reminder. Whoops. There we go. And I'm going to write these ones down. Okay, so try this one first. We'll go 7/8 times 1/5. All right. Then let's do I'm going to save that one for a sec. Let's do this one. Three and a third times 1 1/8. And I got one more for you. Ahmed, this one's for you. 2 times 1 3/4. Okay. If this one trips you up, don't worry. I'll do this one. So the first one, so that one's fairly easy, because remember, when we're multiplying fractions, we just go across numerator to numerator, denominator to denominator. So 7 times 1 is 7. 8 times 5, according to the clock, it's 40. And there's not much I can do with that. I can't go any lower, right? Because there's nothing that I can do equally to both that will go any lower than that. So that is our final answer for that one. So with this one here, I'm going to, remember, turn these into impropers. So times and add, times and add. So essentially what I'm going to end up with is 9 plus 1 is essentially 10 over 3 times 8 plus 1, 9 over 8. Right, again, just to make sure we're seeing all those steps. Right, so 10 times 9, 90 over 3 times 8, which gives us our 24. Woo! Well, we can take a look at that improper, and again, see it as 90 divided by 24. And I'm not going to lie, I got my calculator in my hand. 90 divided by 24, I'm left with 3 wholes, right? 3 times 24 gives me 72, so essentially it's going to be 90 minus 72, right? Take that, left with our 8 and 1. So 18 over 24. Sorry, I was just making sure the camera was recording. But here's what I was saying about take a look at your fractions. We can bring this down to a lowest terms, right? The first number I always go to just for quick shits and giggles, I always say, okay, 2 even numbers. Well, I know they can split in half right away, right? 9 and 9 is 18, so we can say 3 and 9, 24, 12. But I still can come down. Here's where I said normally an even and an odd, that's usually the lowest. But there is still something that will go into both of these numbers. 3 will go into 9. 3 will also go into 12. So let me just get that whole number out of the way. And now 9 divided by 3 is 3, because 3 goes into 9 3 times. 3 goes into 12 4 times. Right? So again, still equal value, just this is a nicer way of writing it, because I can't really find 3 and 18/24 on a tape measure. It's awfully hard to also find 3 and 9/12, but I surely can find 3 and 3/4, right? There's my 3, 1/4, 2/4, 3/4, right? So I brought this into something more readable for my situation. All right? So pretty good, pretty good. Now, for this crazy little sucker right here. I don't know if you guys heard Ahmed at the beginning say something about putting a whole number over a 1. And that's exactly what we're going to do. Not only am I going to turn this into an improper fraction, right? So by doing this to this, I'm also going to just take the 2 and put it over a 1, right? So then essentially how this will read out is now going to be 2 over 1 times 1 times 4, 4, 5, 6, and 7, 7 over 4. And now I just go right across the board, right? So 2 times 7 is 14. 1 times 4 is 4. But I can certainly change this improper into a mixed number. Something that would be easier for me to read, say, on a tape measure. So, again, 14 divided by 4. 4, 8, 12. Well, it goes in 3 whole times, right? 4, 8, 12. So then I say 14 minus 12, right? And I'm left with 2 over 4. But again, I can bring this 2 quarters to something more readable, or at least that it sounds proper. 3 and 1/2. Again, remember, 1/2 is equal value to 2 quarters, right? And again, something that I can read on my tape, right? There's the 3, right? There's my 1/4, 2 quarters, or half. All right? Does that make sense, folks? Clear as mud, as they say? Anytime you have a whole number, right, multiplying by some others, just drop a 1 under it. Okay? So that's multiplying.